Today we will start our discussion about Java. As we said before many times, Java is another object-oriented programming language, and from the first time on, they designed Java as an object-oriented programming language. It's not like C or C++. C++ said that, okay, I'm going to be a object-oriented programming language, but it had to be compatible with C. Also, it has to make lots of decisions about this performance issues. So some trade-off were there, speed versus the object-oriented rules and etc. Java says that I will not be concerned much about the efficiency. Of course, it is important, but it is not as important as being an object-oriented programming language. So it is designed to be a purely object-oriented programming language. But mistakes can happen. Some of the fundamental decisions made by Java designers, creators, turn out to be wrong. Later they didn't like it. That's why they kept changing the language a lot. But the intention for the Java was, okay, let's keep the idea of this being efficient in terms of CPU time and the memory. Let's set it aside. Let's try to make a programming language that is purely object-oriented. Some people don't like it. Some people say that any compiled language cannot be object-oriented. A truly object-oriented language should be a interpretive language like Lisp or Smalltalk. But those are some deep discussions. We are not getting into those discussions. You'll talk about them in your third year programming languages course. Today we are going to see Java as another example of an object-oriented programming language, and we are going to see the differences between C++ and Java. Okay, and that will give us another chance to look at these basic object-oriented programming rules: abstraction, encapsulation, inheritance, polymorphism, code reuse, and etc. Okay. So the originally Java, it started for intelligent consumer electronic devices like the TV sets or your entertainment system in your car, or in those days in 1990s maybe your handset telephone sets at home. Okay. Then during the same time, this World Wide Web stuff came out and it became very popular, and then people said that why don't we use this nice language for the www server functionality, maybe write some code for the client side software and etc. So while technology was developing in other areas, Java kind of found the opportunity to present itself for those kind of platforms. Okay. Nowadays they use Java especially for enterprise applications. Okay, for example, for large banks, they develop their software for especially for that bank, or for some government institutions and etc. And also this is done less and less, but doing it for the intelligent consumer electronic devices. This is done for less and less, but as you know, the most popular cell phone operating system, Android, if you like to write a practical code on it, you write in Java, right? So it's a very popular popular programming language. It always, for the last 10, 15 years, it always ranks at the top 3, 4, okay, along with C, C++, Java. Nowadays Python is taking up, and it's both popular. It's a nice object-oriented programming language. So, and that's why we like to look at this language as a case for object-oriented programming. So before starting, let's look at how we write and compile our Java programs. Okay. This is one of the main differences between C, C++ and Java. Okay, it's not because it is object-oriented; it's because it is done in a different way. Because its intention was consumer electronic devices. Okay, With the consumer electronic devices at your home, for example, as I said, your TV set, I don't know what else, your refrigerator, your oven, your door ring, and etc. They all have microprocessors in it, and somebody has to write programs on it, right? So each processor is a different one because they are very cheap devices. You cannot use standard Intel-based i5 processors on them. So each one has its own instruction set. Each one has its own set. So Java said that this is what I am going to do. Okay, this is your CPU. This is your CPU. Usually your hardware, okay, CPU and hardware. Usually your operating system works on it. It is either Windows or Linux or some other operating system. On top of it, okay, your compiled programs run, okay? For example, a.out, right, for our C program. What do? We have file.c, we compile it to file.o, then we link it to produce a.out. So a.out works on top of the operating system, and this one works on top of the hardware, okay? So a.out directly communicates with the operating system, okay? It asks the operating system to write something for you on the screen. It asks the operating system to get a number from the keyboard. This is how it works with C, C++, or another regularly compiled language. In Java, things are different. Okay? Again, we have our similarly CPU and hardware, and we have our operating system on it. On top of it, they run this special program which is called Java Virtual Machine. Java Virtual Machine. Okay, it's called JVM. It's a software, yes. It's software, and it is used for running Java programs, actually. So if you have a Java program, let me write a Java program here. Let's say file.java, okay, and you compile this through a Java compiler. It produces a file.class code, okay. This one is called file.class. This is bytecode. This is not assembly code or anything, okay. And there is a loader, okay. There is a loader that loads this on top of this Java virtual machine. Your file class works on top of this software, okay. So why did they do such a thing? Because they said that doesn't matter if you have a different CPU or operating system, as long as you have my Java virtual machine on your system, my compiled code will work everywhere, okay. So it can work on the refrigerator, it can work on the microwave oven, it can work on the TV set, or it can work on your computer. Doesn't matter, okay. So these operating systems could be real-time operating systems, very primitive operating systems, very complicated operating systems. Doesn't matter. What's the difference between C, C++? Your file has to be compiled for different environments all the time. So you write your program once, okay? You compile it for different environment. You compile it for the Linux, you compile it for the Windows, you compile it for the Mac operating system, and etc., or Android operating system. But Java says that you write it and you compile once, your compiled code will work anywhere, okay, as long as there is a Java virtual machine. So what they do is, for a given platform, they write this Java virtual machine, Okay, any code that I have compiled on Linux or Windows or Mac OS, doesn't matter. It will work on my Java virtual machine. Okay, so that makes it a lot flexible compared to C++. It's a lot flexible. That makes it a lot flexible in terms of portability, because you compile it once and run it in anywhere you like. But on the negative side, you have to run it through an interpreter, through a virtual machine, which is software. This one is software and this one is software too. So they are using the same CPU. That means that your code is going to run a little bit slower, okay, than the original compiled C code. Okay, so that's how the Java programs are compiled and run. Okay, you use a let me compile a Java program for you. Okay, here it is. Here's your first Java program. It writes welcome to Java programming on the screen. Okay, class definition, public class welcome one. Okay, so the name of this file is the same as welcome one, and there is a main method. In Java we call these methods, not functions. Classes are classes, okay, functions are methods, and then what? And then I write this main method. It's a public method, void method, and a static method. We know what static means. We know what void means. We know what public means. We all know those. And this is a class. Okay. There is an object, a constant object defined in that class. Out. It's like cout. Println is a method that takes a string or any object and it prints on the screen. That's it. Okay. So when you compile and run this, it will write welcome to Java programming on the screen. And I think I copied this somewhere from the, yeah. I think it is, its name is welcome Java. Let me show you that. Welcome Java. Okay, here it is. Public class welcome and system out printf. Is it visible? Not much. Could you pull those curtains down a little bit? And you too. Yeah. Pull them down, yeah. I don't know. Is that good? Can you guys see it now? Yeah, I think so. So this is the program itself. Very simple. And I am going to compile this. How do you compile this? The name of the Java compiler is Java C, Java compiler. Okay, simple enough. And I say welcome Java. It compiles. If there is no error, it's not going to tell you anything like the C++ compiler. Now I have this welcome.class. See this one? Welcome.class. This is our byte code. This is not assembled code. This is not machine code. This is the byte code only JVM can understand. Okay? This doesn't depend on any CPU or any operating system. So I can take this Java class. This is a Windows machine. I can take this welcome.class and I can run this on my cell phone directly on a Java virtual machine, or I can run this on a Macintosh operating system or a mainframe operating system if there is a Java virtual machine is available. Yes?
Bytecode means a binary file?
It's a binary file and it contains instructions, but those instructions are not instructions for the CPU. Those instructions are instructions for the Java virtual machine. Okay? Java virtual machine, as the name implies, it's a virtual machine. It behaves like a machine, but it is software. Okay? It has its own instructions, and instructions doesn't look like the CPU. What is the CPU instructions? CPU instructions are usually like registers moving stuff around, doing multiplications and additions and jumping around, etc. Right? Java virtual machine instructions are a little bit different from those. Okay? Because it's a software, it is a little bit more high level, but nevertheless, it's a binary file, and its size is very little, as you see, very little, 400 bytes, right? And to run this welcome.class, you need another program. So you will say, run this. Java virtual machine is Java. Okay, I type Java down there. Java is Java virtual machine. The name of the Java virtual machine on all the operating system is Java, and I can just say welcome. Okay, Java welcome that class. Okay, and it runs. It says welcome to Java student. I don't know why. I don't know why I had. Was it this? Okay, I compiled it. I am going to. Was that the string? Yeah, yeah. Well, it says this one uses printf. Remember printf?
Yes.
We like printf a lot, right? Did you miss it? So in Java we have printf. Okay. But the thing is that, what does this one say? I am going to print a string here, right? If you don't provide a string, if you provide a double, this compiler will give you an error message. Because Java is a very strongly typed language. Okay. So instead of student give a double here, you will get a compiler saying that this method doesn't take a double, it takes a string. Okay. So it is not like it looks like a printf, but it is not like a printf. It checks all the parameters, and it doesn't have a scanf, but you cannot make those kind of mistakes, which is very easy to do in C or C++ in Java. Okay. Yes. Is this your first question?
No.
Did you ask a question before?
Yeah.
Okay.
I usually come on Tuesdays. I usually come on Tuesdays.
I don't remember the dates. Sorry. Okay.
In the void main, the string argument is always string, or just because of we use the string?
Those are command line arguments, like in C, C++. Those are used for getting arguments from the command line to your program, and it is taken as a string array. This is string array. Okay? It is always like that. You have to take strings, and I have a sample program for that in a few minutes coming. Yes?
I don't understand why there is a public class welcome.
But I didn't talk about that yet. I will talk about it. Well, I didn't tell you anything about Java programs yet. I am talking about Java, how to compile a Java program and how to run a Java program. And I'm talking about this cycle here. Okay, you edit, you compile, you load, verify, and execute. Okay, so we talk about here two things. One is the Java compiler, which is named Java. The other one is the Java virtual machine. This is Java compiler is Java C, okay, and the Java virtual machine is called Java on Linux or Windows. Once you install your Java development environment, Java development environment, okay. With the Java development environment, you receive Java compiler, okay, and Java virtual machine. Okay, this is for the developers. This one. But if you install your Java runtime environment, JRE, for this one you receive only Java virtual machine. Okay, most people who don't do development, they just install this Java runtime environment. Once you have Java runtime environment, you can run any class file, binary bytecode file that is compiled before. And remember my favorite, what was my favorite internet site? Yes, and that Compiler Explorer has, to my surprise, a Java compiler. and I tested it last night. It works. Well, I didn't run any programs, but okay, this is my Java program. Is that a Java? Yes, this is a Java program, class square, and there is a public static void main. Okay, I said compile it. It compiles, and this is the code it produces. This doesn't look like any code that we have compiled before, right? This one has a function in it, and the instructions are almost understandable, right? So this one is, let's look at this 478. Yeah, this, what does this one says? I have an integer 2 and store it 0, and I have another integer 1. So one of them will get 2, one of them will get 1, and these are my stores. I am going to call them 0 and 1. So this one says that increment it. Increment 1, increment integer number 1, then load it and store it to the variable number 1. Okay? And you see invoke virtual. So I am invoking a virtual function, it looks like. We call it methods. Okay? So it is almost understandable in bytecode. As I said before, no CPU reads it. This is read by the Java virtual machine. Okay? Of course, this is not a high-level language. Of course, you are not supposed to write in this language, bytecode. But I am showing this to you just to tell you that bytecode is different from the compiled C++ code, because this one does not depend on the CPU. Okay, and our compilers are like that. Okay, these are the compilers. Java Development Kit 17. So these are kind of the Java versions, and 17 is a large number. So they have released 16 more before just 17. And in fact, you can look at them. What's the difference between 16 and 17? It's only incremental. It is not much, but there's a difference. And usually, I mean, we don't have a very major release of Java like C++ 11 or 20. Okay, they incrementally keep changing the language, and I am going to, I mean, as far as I know, I am going to tell you, okay, this one has been added at like 7, this is 5, and etc. But most of the time I forget. Okay, good. So let's go back to our slides. Okay, so talked about the. So this is the. I mean, if somebody asks you what's the difference between Java and C++, okay, you say, well, they are both object-oriented programming languages, but I mean, as a way of using it, Java is kind of like an interpretive language, right? What's the difference between the compilers and the interpreters? Compilers compile the program once, okay, and everything runs on the CPU. Interpreters, they compile the program one by one. Java is kind of in between. Java compiler compiles the whole code into byte class, okay, bytecode. Then bytecode is run by this Java virtual machine, which is an interpreter actually. It reads, Java virtual machine reads these bytes one by one and executes them, okay? Java virtual machine is not a compiler. And maybe you can call it like an interpreter, but it's not a compiler. So it reads this one, executes it, and this one, then that one, then that one, then that one. If there is a loop, it keeps doing that, okay? Of course, they try to make it efficient, but as you can see, while your Java bytecode is running, it is being interpreted. Another program is being is interpreting it, so that makes it a little bit slower. Okay, that makes it a little bit slower. How much slower? Maybe 2 or 3 times slower than C. Maybe 2 times slower than C++, and maybe 3 times slower than C. Something like that. Okay, but for the enterprise application, doesn't matter. For the enterprise applications, all they do is they just access the databases, do some user interface stuff, some sorting, some comparison, some communication. That's it. Okay. So usually they have more than enough CPU power. They don't write operating system critical code. Okay. So for those kind of people, efficiency of the software developer is more important. That means that if the program is better suited for object-oriented programming, that's the better news than the efficiency of the program itself. If you are writing a operating system stuff, okay, if you are writing performance critical tool, then C is the language. If C is not enough, then you are going to go back down to assembly. Okay, that's the rule of the game. But if the performance is not that important for you, fast development, being more object-oriented is more important. Maybe Java is the solution. Okay, and if you like to go even faster, okay, with no regards to software engineering, then go all the way to the Python. Okay, Python is fastest in terms of developing something, but it is all crappy code. You know, I mean, it's a toy language. Okay, so that doesn't mean that you cannot develop large software code with Python, but it has its own limitations in terms of being used by the team and etc. Okay, let's go back. Let's go back and let's go to the slides again. So typical Java. Okay, your editor, you edit your Java program, you compile it using your Java compiler. Okay, that Java compiler will give you the bytecode, and this bytecode will be loaded by the Java virtual machine in your memory, and somebody verifies it. Because it is very dangerous to receive bytecode from the internet. Once you receive it, it is runnable code, right? It's runnable code. If you're very dangerous to run some code that you have received from internet, because that code might contain malicious software, so it has to be verified. Okay, there is a bytecode verifier. It verifies the bytecode, then your Java virtual machine runs your program. Okay, your Java virtual machine runs your program. Good. Okay, let's look at our first program again. Java programs, a runnable Java program, an executable Java program should contain a main method. Okay, in Java we call them methods. Let's try to have a, where should I put it? Maybe I should put it at the beginning, or maybe I'm going to do this here. Okay, maybe I can do it here. Okay, let's do this like that. Okay, its name is going to be Java versus C++, and I am going to add a table here like that, and I will keep adding. So this is C++, and this is Java. In C++, things that we call, why don't I, okay, maybe do that and do that. Oh, I forgot about your attendance. Let's start from the okay, so in C++ we call functions. In C++ we call functions. In Java we call methods. Okay, so some terminology. If the name is the same, then the meanings are the same. Okay, in Java we have classes, and C++ we have classes, so the names are if the names are the same, the meanings are the same too. Okay, Java is designed to look like C++ or C. Okay, because they knew that C programmers and C++ programmers will move to use Java, so they made it similar. So if the names are the same, then the meanings are the same. For example, the keywords public, private, protected, integer, double, long, boolean, etc. These are all the same because the meanings are all the same. But there are different things. For example, in C++ we have const keyword. In Java we don't have const keyword. Instead we have final. The meanings are not the same. They are similar, but the meanings are not the same. Okay, the meanings are not the same, and we are going to talk about them. Functions or methods are similar, but they are not the same things. In Java, you have to have one main method, but as I said before, Java is designed to be a purely object-oriented programming language. So you cannot write global functions, or you cannot declare global variables in Java. So what do? I have to make this a part of a class, and the class name is welcome1, but this name of the class has to be the same as the file name. File name is welcome1.java. Okay, file name is welcome1.java, and the class name is welcome1. Okay, inside this welcome1 I have a method. Its name is main. As you see, main doesn't return anything. Okay, and main has to be a static function. Why it has to be static? It has to be static because Java Virtual Machine is going to call this main, right? Java Virtual Machine calls this main without making an object of this class welcome1. Okay, it just directly calls welcome1.main. How does it know what to call? Because this name of the file and the name of the class, this public class, has to be the same. Okay, so this Java Virtual Machine says that, okay, when I say Java welcome1, I say that, okay, I'm going to call welcome1.main. Okay, welcome1.main is this one. It is a static method and it has to be called that way. Why do we declare our class public? Because I can have more than one class inside the same Java file. Only one of them has to be public, and whatever is public, it has to have the same name as the file name. Okay, usually we write a single class for each file. Each file has a single class. It's a little bit different from the C++. In C++, we can put more than one class inside the same file, but usually we try to put a single class in a file. But in Java, the things are different. We don't put many classes inside the same file. Okay. So you compile it and you run it. Everything works. Let me try to make a little bit changes to this program so that we can see. Let me open a editor. Some editors. Okay, welcome Java. Let me see okay, is this one? My dev C++ opens this. Why don't I? Well, good enough. Okay, let's make some. Let's try to make it give me some error messages. Okay. Instead of saying I have an integer, I am directly saying that assign 1 to A. I didn't declare it. Let's compile it. Okay, this is the error message that you get. What says, okay, cannot find symbol, one error. So Java compiler, that's the error message. And if I say it is an integer, okay, now it's not going to give me any error messages for that one. But instead of printing the student, let's say I am going to print this A as a string on the screen. And did it work? Oh. Okay. Let me see how it runs. It's kind of okay, and it works fine too. Sometimes it surprises you. What did I say before? It checks if this A is really a string, right?
Yes.
Yeah, well, in this case, it didn't give me an error message. What's going on? The thing is that in Java, all the objects can be converted to strings. This is the name of the rule, okay? All the objects can be converted to a string, so A is not an integer. A is not a string. Should I give you an error message? No. Why? Because there is a way to convert an integer to a string. So it did that. So, but if I wanted to, for example, print a double, okay, and I would send this string there. Okay, now let's see the compiler error. It did not. What? Oh, okay. So I got this. Well, I mean, this is a runtime error. Okay, this is a runtime error that I got. You are not going to get anything meaningful, but in some versions of the compiled code, you are going to get a compiler. I don't remember how. Okay, so it didn't print something not meaningful. Okay, it didn't print something not meaningful. It just said that I cannot do that because the parameter that I am getting here is different than what you have promised to me, and that's what I got. But I was wrong in that case. I told you that you are going to get a compiler error here. No, it wasn't a compiler error. Okay. So things are a little bit different. Things are a little bit different, but it looks like CSE++, especially if you forget about Java Virtual Machine. When you run stuff, okay, especially when you are using an IDE development environment, all you do is just compile and run. Most people, Java programmers, don't realize that there is a Java Virtual Machine running underneath. They don't realize it because they just compile and run. When they run, Java Virtual Machine automatically runs, and they think that it's compiled and it's running the compiled code. Okay. So, any questions so far? Yes?
When C or C++, when you mention the type of the variable in printf or something, it automatically changes the type. When give a string function or print it with a float, why does it work in this way?
No, C++ doesn't do that, no. When you say that I am going to print a string and when you provide a double to it, okay, it will print some garbage.
No, in printf function.
Yeah.
Access modifier.
What?
Use the S or use the F. When printing a string,
Yeah.
use the D. It does not give an error.
Yeah, that's what I am saying, because C says that, okay, you are the boss, whatever you are going to give me, I am going to execute it. Java doesn't do that. Java says that if you are going to give me a double, you should give me a double. If you give me something else, I cannot run. Okay, it's a strongly typed language, that's what I am saying. Okay, which one is better? C people say that, okay, this is better because this is what we told the compiler. Java people say that this is not meaningful. I mean, if it has to be a double, then it has to be a double. Don't give me something else. Yes?
Sir, could you please explain one more time what we are using static in main? You explain what
Well, static means that, okay, this method, let's talk about C++. A static function can be called using the class name, right?
Yes.
To call a static function, you don't need an object of the class. Okay? So when I say here Java welcome, Java is the Java virtual machine, right?
Yes.
Java virtual machine say that, okay, this class name is welcome. I know that because class name and the file name has to be the same. So what I am going to call is welcome.main. Okay? It doesn't have to make an object of the welcome class. Okay? It can call directly the main method. Okay? So that's the design decision they have made. 20, 30 years ago, 20 years ago, 30 years ago, yeah, 30 years ago, and that's the rule, and you can explain it this way.
Thank you.
Sure. Any other questions? Yes.
In C++, when we define a class, we put semicolon at the end, but here we don't. And you said
Yeah.
it's an important difference.
Oh, you remember that? It was at the beginning of the semester. Yes, definitely. Yes. Well, I am not going to. That's a very good question. In C++, when you define a class, you put a semicolon at the end. In Java, you don't. Okay, you definitely don't. And that's one of the main differences between Java and C++. That's what I said at the beginning of the semester. I cannot give you the answer right now, but I think either at the end of today or maybe tomorrow we'll talk about it. That's one of the main differences between Java and C++. Not just because you put a semicolon or in there or not there, it's not the difference. The reason why we are omitting that semicolon is very important. Okay, we will talk about it when we talk about the Java objects and variables. Good. So don't let me forget it. Okay, I should talk about it. Any other questions? Okay, if there are no questions, then let's move on. Let's look at this other program, another program. I have two programs. Okay. Another program. This one will let me run the program. Let me show you what's going to do. It will tell me enter first integer 45, enter second integer 72, and it will add them up, and it will say sum is 117. It is as simple as this. For this one, I will write two classes. Okay, one class is, well, obviously very stupid program, but okay. One class is this addition. Oh, sorry, it's not two classes, just one class. Sorry, just one class. Okay. Class name is addition. Okay. Inside this class addition, I have my main method. Of course, the addition class and the name of the file is the same. Okay. And did everybody? Abdullah, where have you been? I didn't see you for the last 2-3 weeks.
Yes, I overslept.
Okay. Did everybody sign this? Anybody? You guys are using the same pen? Okay, so name of the file and the class name is the same. My main method and line number 3. Import is very similar to using, but it is not the same, of course. Using import. They are similar, okay. They are not the same. As I said, if they are the same, then we use the same keyword, okay. Using and import are kind of the similar. And in Java, we don't have the namespaces, but we have packages, okay. We have this Java util package, and inside there is the scanner class. I am using that scanner class. I am importing it. Scanner is going to be used for getting information from the keyboard or from the standard input, whatever you call it. Okay, so here is the code. I make a new scanner object, okay, using the keyword new. As you see, keyword new is the same as the C++ keyword new. Their meanings are the same. On the heap, make a new scanner object, and this is called a reference. Okay, in Java we use references a lot, but in Java reference is not like a C++ reference. They are very, very different. Let me try to put it in there. In Java, references are very much like shared pointers. They are smart pointers, okay? So you don't delete them. In Java, there is a new keyword, but there is no delete keyword. You never delete anything. Everything is deleted automatically. It's like how the shared pointers are supposed to be, right? With the shared pointers, you don't delete anything. You just make a new object. When the object is not referenced anymore, it is deleted automatically. The destructor is called automatically. In Java, the objects are like that. Okay, you make all the objects using new. There is no other way. Okay, in Java, there is no other way of making an object. You have to use the keyword new. Everything has to be on the heap, and you never delete them. There is no delete keyword in Java. Okay, so this is what I do now. I make a new scanner object, and the scanner input is a scanner reference. Okay, this is Java terminology again. I am scan is a Java scanner reference, and I make 3 integers on the stack. Okay, you might say that how come you did not make those integers on the heap? These are called fundamental types. Fundamental types are created on the stack. Okay, they are not created using new. New and int doesn't work. You cannot say new int. Okay, there is no new int. There is something corresponding to it, but there is no. You cannot say new int. Okay, we will come to these details later. So far, what do I have? I have 1, 2, 3, 4 variables. Okay, one of them is a reference. 3 of them are integers, and I have an object on my heap. There are 5 things going on right now. Okay. And now I am calling this print line or print, system out print. The difference between print line and print is that print doesn't put an end of line at the end. Print line prints an end of line, \n. Okay, so that's the difference between print and print line. Okay, number 1, call next int method for this input. Okay, so input is pointing to a scanner object. So I am calling this next input, next integer method on this input. So it's called next int, next integer. I get the integer, it returns an integer, and I assign it to number 1. And I do the same thing again for the number 2. Addition, assignment, the meanings are the same for integers. And I use the printf to print it out. And that's it. And I just compile this and run this. Okay, compile this and run this. Good. So that's our second program in Java. Is a little bit more complicated. We read some data from the keyboard and we print it out. And we have still a single file. Still have a single file. We use how to import is not include. In Java there is no include. Okay. In Java, there is no include. In Java, there is no, this is going to be shocking, there is no header file. Okay? You don't define any header files. There are no standard header files. You don't include header files. This import is like using statement. Okay?
Just class?
What?
Just class we can import.
Yeah, just Java files. There are no header files. Okay? So you don't write header files. You don't separate your class definition from the implementation. Once you start writing a class like this, you have to put all of your methods, including their implementation, inside that class. Okay? But how about the documentation then? How about the documentation? What am I going to give my customer, right? What am I going to give my customer? If there are no header files, we give our header files to the customers along with the compiled code, right? In Java, you don't do that. In Java, there is a mechanism called Javadoc. Java documenter, Java documentation tool, utility. This one scans your classes and it produces a nice PDF file or the HTML file for you. That will tell you, okay, these files have this class and this class and this class, and these are the methods of it. Okay, now you can use them. Let me show you one example, and after that we are going to take a break. I have this, yeah, Adnan Java. This is one I have downloaded from this from somewhere. This Adnan is very simple. Okay, Adnan is a very simple class again. It just imports something. See, this is kind of a little bit different. It starts with slash star star slash star star means that this command is important. This is going to be part of the the documentation of this class, and these labels are very important. The author of this file is this guy, version is this, and he is working on this file since this date. Okay, and this class Adnan, again, the stuff about this function, how it works, is takes that it will take two parameters and it returns an integer, and this is the main method and the documentation of it. And it looks like, what does it do? It say that I am going to make a new add num object, and I am going to call it, well, I'm not going to read this, but I'm going to do this now. Let me compile it. Java compiler add num Java. I compiled it, and I am going to run it. Okay, sum of 10 and 20 is 30, that's fine. As you see, I have Adnan Java and Adnan class, and I'm going to call this Javadoc Adnan what's going on? Add. Okay, I think this stupid thing is not working. Okay, so the Javadoc is working and working and working. It created lots of, it looks like it created the HTML document. Okay, so if I look at this, did you see that? It produces lots of files, and one of them is index.html. Let's open my Explorer window now. In my Explorer window, let me refresh it. Okay, so my Explorer window became like that. Okay, so let me find this index.html. Where is my index.html? Here it is. Okay, it's the HTML file now. It is automatically produced out of my code. As you see, class addNum. Okay, it extends Java lang object. It's talking about its hierarchy, and it has two numbers. These are directly from our code. Okay, this is my constructor. I did not give any constructors. It is the default constructor. These are the functions, addNum and main. These are the parameters, and when I click on this addNum, I go to another file, and this one now explains me all the stuff. Okay, so this is all automatically done using my Java code, and if I use that Javadoc commands in a right way, in the proper way, such a nicely documented files can be produced, either PDF or HTML, or like the Windows app stuff, etc. Okay, so they don't use include files. They don't write include files, header files. Okay, they put all the information about how to use those methods and classes inside the class documentation using these special coding style or the commenting style, and everything handled by the Javadoc. Okay, some people like this much better than headers. One way of doing it. Even some C++ people like this much better than headers. That's why they use a similar utility for the C++ programs too, because there are similar utilities for C++ programs. They will scan your header files and the source code, and they will produce such nicely formatted PDF or HTML files. Okay. Okay, let's take 10 minutes of break. Let's be here around 10:45. Let's open all the windows, people. Things are getting worse. This new virus variant is not a good thing. Let's open all the windows.
Hocam şöyle hocam. Hocam Kotlin aslında buna göre daha rahat olur.
Efendim?
Kotlin var ya hocam. Java'ya göre sanki bir tık daha rahat.
Ne?
Kotlin. Programlar var ya Kotlin hocam. Java'nın şeyinden. Sanki Java'ya göre bir tık daha kolay yani.
Kolay ne demek kolay? Kolay istiyorsan
hocam.
Python en kolay.
Encapsulation'ı her seferinde public static falan yazmaya gerek yok. Yanında constructor'larda getter static yok.
Daha mı az yazıyorsun?
Evet.
Daha az yazmak daha kolay manasına gelmiyor mu?
Daha rahat bir sanki ama.
Tamam, sen ondan kullan, ben bundan soracağım.
Hocam bir yere derste demiştiniz ya, her obje string'e çevrilebiliyor diye.
Niye?
Her
Ha,
obje
evet.
string'e çevrilebiliyor.
Evet. Ondan sonra konuşacağız.
Buna değil mi dahil o zaman? Ben kendim atıyorum yine de yapıyor bir class tanımı falan.
Evet, şu edition var ya, edition class'ın objeleri string'i çevirebiliyorsun. Eğer override etmezsen onun behavior'ını saçma bir şey çeviriyor. Override etmen lazım. Bak çoğununki override değilmiş mesela, ETC'li güzel ediyor.
Biraz bu bakalım. Biraz da bakalım. Aslında bir Java'nın
Tam adını Ozan mısınız?
Evet, Emir Tanrı.
Az çok bilmiyorum.
Çok şey oluyor, herkes hafiften daha iyi. Değil mi?
Salı günü gelen herkesin özel
Onlara geldi mi ki? Onu severlerse orada yok.
Şimdi kargoda alacağım. Yarın da neye geliyorum? Javadoc. Yarın da öğreneceğim. Doğru.
Bir tane proje gelecekmiş. Yine mi Eagle?
Yok, bu muhtemelen şey, mobil platform.
Okay, so let's look at the other program actually. Let me show you this one, the one that produced all that, Javadoc documents. I have this class Adnan. It has one public integer method. It takes two integers. In Java, you write your access modifiers at the beginning of each member. Okay, either the methods or the data members. We call them fields. Let me write this. Okay, in C++ we call them data members. In Java we call them fields. Okay, so in this one, I provided my access modifier public here. Okay, and this is just a function, and this is my main method. This is just a method. Sorry, this is my main method. It says that I am the main method. These are my command line arguments, and look at this one. It's interesting. It makes a new object, Adnan. What is Adnan? Adnan is my class name. See? It makes an object of this class inside the static member method, and its name is object. For that object, I call this Adnan method with two parameters and returns the sum of it, and I print it with this one, sum of 10 plus 20 is plus sum. This plus here is the plus for what kind of plus is that? What kind of plus operator? Plus for what object? What type? It is for strings, right? Because this one is a string, this one is a string, this one is not a string, but as I said before, in Java there is a way to convert everything to strings. So this plus, in order for this plus to work, both sides has to be string. So I can convert to a string. I converted it, and it became like string catenation. Okay, string catenation. So print line works that way. So I made an object of this class, okay, Adnan, and it worked. Okay, obviously this is not a very good method. Why? Because this method doesn't use any fields of this class at all. Okay, it takes everything from the parameters and it adds them up and returns it. Okay, this looks more like a static method. But for the sake of example, we did something like that. Okay, good. Any questions? Go back to the slides. This is our second example. We talk about import here. We are going to talk about packages a lot today or tomorrow. And what else? Okay, this is how you make a new object. And as I said before, new is the only way of making a new object in Java. In C++, I can make object. Let's talk about, let's remember our money class. In Java, in C++, I can make a money like that. Money M1, M2, $10.20. Okay? Or I can say I have a money pointer MP new money $10.05. This is how we do stuff in C++. This M1 and M2 is created on the stack, right? These are my local variables. Okay, this is in the created in the stack. Let's say my curly bracket begins here and ends here. When I end it here, this M1 and M2 will be automatically destroyed, right? Also MP will be destroyed, but this money created on the heap will stay there, right? That's what I know. In Java, if I try to do the same thing in Java, okay, if I try to do the same thing in Java, I'm going to write it in green, okay. In Java, you would say, let's say I have a class named money in Java. You would say I have a money M1, okay. This is not a money object. This is a money reference. This is a money pointer, okay. This smart pointer, you may say, okay. In C++ terminology, this is a money reference, and money references can keep, okay, references to money objects, okay. Money $10.20. Okay, I'm trying to, oh, come on. Okay, let's not argue with the editor, right? Okay, so $10.20, and let's say my scope starts here and ends here. Whenever I reach here, okay, this local M1 is a local object. It's on the stack. This dies. When it dies, nobody points to this object anymore, and this one will die too because this is a smart pointer. Okay, there is no such thing as, this is 20 cents. Okay, there is no such thing as 10 and 5. There is no such thing as money M1. Okay, when you say money M1, it is just a reference. There is no object creation on the stack. You cannot give names to the objects, okay? There is no name for this object. In C++, you can give names to the objects. Like M1 and M2 are the names of the objects, okay? This one doesn't have a name, but I am pointing to that one using a pointer like MP. MP is the name of the pointer, not the name of the object. In Java, okay, M1 is the name of the reference that references to this money object. Okay, these are for the object types, but for the integer types, you can do it like integer I1 initial value is 0, or double D1 initial value is 1.0. For the fundamental types, it behaves like C++. For the fundamental types, there is no new, okay? For fundamental types, you only say that, okay, I have an integer. So this is on the stack, and this is on the stack too. And they are automatically destroyed when the scope ends. So that's the one of the biggest differences between C++ and Java. Your question, back to your question, or my question too. Okay, this is the AND class addition. Why don't we put, let me do it here, okay? Again, divide it into 2. when you say in C++, and this is Java, in C++, when you say class A dot 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 whatever, you can say object A, right? What did I do? I defined a class named A, and I declared an object A of type class A, right? That's what I did. In Java, you can say class B dot 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 dot, okay? You cannot say an object B here, okay? This is not a valid notation, because class objects cannot have names. You cannot say, there is only one way to make objects of a class. It is the new operator, okay? But in C++, you have both new operator and the regular way of declaring your objects. So since this is not possible, you don't put a semicolon at the end of the class definition. Usually, if I omit this one, okay, that's what I do. I put a semicolon to show that I am not declaring any objects of this class, right? That's what I'm saying. I am not declaring any objects of this class. That's the meaning of it. But in Java, it is not possible to declare an object of a class here. That's why no semicolons are required. Okay. That's the. I mean, obviously, semicolon is not one of the biggest differences between Java and C++. The biggest difference is in Java, you don't create objects. You can't create objects on the stack. You need the new operator. Okay, you need the new operator. All the objects are dynamically created, and there is no delete operator. To delete an object, the reference count had to drop to 0. Okay. Good. So one of the biggest differences between Java and C++. So there is no pointer issue in Java most of the time. It is very difficult to make a pointer related error, logical error in Java, because they don't let you touch your objects anyway. Okay, all the objects had to be in the heap, and they are automatically deleted. There is no destructors in Java. Okay, there are constructors, but there are no destructors. Okay, instead of destructor, there is something else, but it is not the same as destructors. And you might think that if I have the new operator, dynamic memory allocation is there. Yes, that's true. If there is a dynamic memory allocation, then there is a memory leak and there is a dangling reference problem. That's not true. No. It is very difficult to have memory leaks or dangling memory reference in Java because all the objects are dynamically managed, and from time to time there is in Java virtual machine there is a piece of software called garbage collector. Garbage collector runs time to time, and it deletes all the objects that are not used anymore. Okay, so it deletes all the objects that are not referenced anymore, and you don't know when the garbage collector runs actually. Okay, it is the task of the Java virtual machine to run the garbage collector from time to time. So it handles all that kind of stuff for you, and so for the developer, for the software engineer, the life seems a little bit easier because I don't have to think much about the memory. As long as you are playing the game by the rules, you should be fine. Of course, all of these conveniences doesn't come cheap. They will come at the cost of some CPU performance issues, CPU performance penalties, and the memory usage penalties. But as I said, many people don't write performance critic software. Important thing for them is the development speed. If the development speed is good, and if I can work with the teams, and if my code is maintainable and reusable, then I am fine. I can take 50% CPU penalty time. That's fine. Okay, but if you are doing something time critical, then it has to be C. Java compiler is written in what? Java compiler itself is written in C, C++, of course. What do you think? They write the Java compiler in C++. They write the Python compiler in C++. They write all the operating systems in C++. So, I mean, if there is something very frequently used, performance related, it has to be very, very carefully written, then it is C or C++. Okay? But if you don't have to think about like memory utilization, efficiency, and that kind of stuff, Java is maybe a better way of writing software for those kind of cases. I am not saying that C is best programming language available, or C++, or Java, or Python. I am not saying that Python is a bad programming language. I mean, since they are there and millions of people are using it, there are now more people using Python than C, Java. I mean, they must have a point, right? Okay. If the things are right, then you should use definitely Python, whatever is popular. Okay. But as a software engineer, as a computer engineer, as a professional of this trade, you should definitely know about the assembly. You should definitely know about C and C++. Okay, that's why in this department we start with those programming languages. Okay, let's go back to Java. Okay, let's continue our comparison with Java. C++. Arithmetic operations, operators, precedence, and arithmetic operations are almost the same. Okay, if statements and conditions are exactly the same. If works this way: if A is less than B, okay, then do this, else do that. Okay, so if works this way. Ternary condition statements are there, but they don't use it much. Or maybe I'm mistaken. Maybe it is not there. I don't remember. But they don't use it much. What else? Operator precedence is there. Okay. A gets the value of B, gets the value of C, gets the value of 1. Will work. There's a right to left associativity. And this is A gets the value of B times C plus 2. Definitely this is going to be done first. Precedence is higher. And precedence, as I said, all the other rules are very similar to C++. Class definitions are very similar to C++, of course, with some differences. Access modifiers are there, public, private, protected are there, and their meanings are the same. Public, private, protected. But the thing is that for every member of the class, whether it's a method or the field, okay, data field, you have to put this public, private, or protected at the beginning of it. Okay, if you omit it, it has some other meaning, and we are going to talk about it. Okay, so there is no, like in C++, there is no public section or private section. Okay. For every member, you have to specify it's a public, private, protected. In C++, usually we try to put the public section first. You list all your constructors and public functions first, so that whoever reads your header file can see whatever is available, right? In Java, there is no header file, okay? So you don't have to collect everything together. You just write them the way you wish. Of course, we prefer writing the constructors first, but it's up to you. So it is the task of the Javadoc utility to make them look nice in your documentation. And there are lots of options for the Javadoc. I mean, what do you want to do? What kind of documentation you want to produce? I can produce all your. I mean, for your internal documentation, I can produce the documentation for your private methods too, private data too, right? I can do that too. It's up to you, depending on the switches, or if you want to put your constructors at the beginning or that kind of format, etc. So, as I said before, there is no grouping of the publics and privates together in Java. We write them one by one. In Java, there are no functions. They are called methods. By the way, the standard object-oriented programming terminology calls them methods. Okay? And in Java, class data members are called fields. or instance variables. Okay, instance variables. Let me put that there too. Okay, these are fields or instance variables. Okay, in Java there are no global functions, there are no global variables. Everything has to be in objects, everything has to be in classes. Okay, there are no global functions. Even our main is not a global function, global method. You have to write at least one class. Inside that class there has to be a main method which has to be public static void. Otherwise Java virtual machine cannot call it. Okay, static methods and static data member are same as the static member functions and static data members. Okay, and static members are declared like in C++. You put static keyword at the beginning of them. Okay, and we said something like this: there are no global functions, right? How do they calculate the sign of 1.0 then? This is what they do. They say that there is a class named math. There is a static member method inside this math, and you just call it. So they made those kind of methods static methods of some class. Okay? So sign is not a global function, global method anymore. It is part of a class. Since I don't have to make a new object of that class to use the sign function method, then I made the sign static so that I can call it directly on the name of the class itself. Okay? Good. Again, for constants, Java uses keyword final, but the final and const keyword are not the same. They are a little bit different. Sometimes they overlap, but they are a little bit different. We are going to talk about them. The main method in an application of a class is static. Okay, the main method has to be static. That's how it does. That's how it works. Good. So that's like 2 or 3 chapters for you at the beginning of the Java book, any book, and we are going to go that way. Okay. So far, I think the most important thing I told you about Java is Java Virtual Machine, Java runtime environments, and the Java references with the shared pointers, similarity with the shared pointers. Okay, so let's talk more about those Java references. There are fundamental types, or sometimes they are called primitives. Okay, they are booleans, bytes, characters, short integers, long floats, and doubles. These are the primitive types. They are not objects. We don't call them objects. They are just types in Java. Okay, they are not used with new. They behave exactly same as in C. Okay, in C, how the integer behaves, these behave exactly the same. Okay, you declare an integer, you use it. Okay, whenever the scope ends, it is killed automatically for all of them. Okay, for the rest, for any class that you have defined, you need a reference to refer to that object. They are called object types, sometimes called non-primitive types. Okay, when you say money M is not an object in Java. M is a reference. If you like to think in terms of C++ terminology, M is a shared pointer. It keeps the count information in it. Okay, it's a smart pointer, M. Okay, and its default value is null. When you say M dot get dollars like this, okay, this one definitely will give you a runtime error. Okay, but I think the compiler will not let you. The compiler will not let you compile this code. It is going to tell you that M is a null. Okay, it doesn't refer to anything. Let's try it. Let's try it here in this code. Okay, I am going to do this, and I am going to do that. Okay, you understand what I did? I am just making an object. I am trying to make an object of add num. I say that add num object. Object is a reference, but it is not referring to anything. It's not pointing to anything. I am trying to call this add num on it. I don't think that this will compile. If it compiles during the runtime, I'm going to get this runtime error. Okay, Java compiler Adnan Java. Okay, it said what? It said variable object may not have been initialized. Uninitialized object. So Java is careful about this uninitialized objects, uninitialized variables. In C, C++, I am sure many of you run into this trouble because of an uninitialized data member, uninitialized local variable. The system gives us lots of trouble. Well, in this case, a Java compiler most of the time tries to handle this uninitialized stuff. Okay. Well, it is not that sure because sometimes it is not this obvious. Well, in this case, it is obvious, right? In this case, it is very obvious that right after declaring this object, I try to use it. Compiler can detect it. But sometimes it is not that obvious because there might be lots of code between these two. Okay. It may not be easy to see that it is not uninitialized. In that case, during runtime, you are going to get a runtime error. Okay. Runtime error. Okay. Since you cannot delete an object yourself, you cannot keep a reference in an invalid state. It is not possible. Well, at least it is easily not possible. You cannot delete an object. So when you initialize an object, you have to initialize it with a valid address. Okay. How do you initialize it? You initialize it with a new. Okay. You initialize it with a new. And other than that, there is no way to initialize an object. Maybe you could say another object, for example, object 1. And if I do the same thing again, here, and now I have another object. Let's say this is object and its value is object 1. Okay, so if I do this, both object 1 and object are referring to the same object, but they are valid things, right? They are valid things. And there is no way that maybe I can do this later. If I do this, object gets the value of null. Okay. That's the only way I can point to an invalid thing, but it's a null thing. So there is no memory leak or there is no dangling reference other than the object pointing to a null. When it happens, you get an automatic runtime error, a null reference, and you would know the error itself. In C, C++, sometimes you point to some place in your memory that doesn't belong to you. Okay, it belongs to you sometimes, but it's a bad place, etc. In Java, it doesn't happen. It doesn't happen. Okay, that's why they say that it is safer to use Java with these kind of dynamically allocated memory stuff. Yes.
If we change object one's data member, object's data member also changes, right?
If what's that object data? We call them fields.
Yeah, object one's data member. If we change it, object's data member also changes.
Sure. Yeah. Well, yeah. I mean, you are saying that these two are pointing to the same object. Yes, they are like the pointers, right? They are both pointing to the same thing. Let's write this here. Let's write this. Where is my main? Where is my? What happened? Trying to connect someplace. Okay, I was trying to find this money stuff. Okay, let me write it in here then. Let me write it here in Java. I am writing this in Java. Okay, Java code. Java code, money M1 new money $10.20, and then I have money M2, guess the value of M1. Both M1 and M2 are pointing to the same place in the heap. When I say M1 set dollars 10, or it is already 10, let's make it 15, okay? Both M1 and M2 are pointing to an object that has a dollar part of 15, okay? If I like to draw the memory, by the way, you should never draw the memory in Java, because they don't know what memory is actually. So this is our memory, this is our stack, this is our heap, okay? Inside my stack I have my M1 and M2, two references. This is on my stack, they are automatic, okay? Both of them are pointing to the same money object, which is $10.20. Since I have changed this 10 to 15, now both of them are pointing to here, okay? You can't say in Java delete M1. You can't say that. If you say that, M2 now is a dangling pointer, right? But in Java, this is not possible. Okay, there is no delete keyword. You cannot kill an object in Java. Okay, in the heap. So that's how they prevented. That's how they prevented dangling pointers. You can say that I can do the same thing with C++ using shared pointer. That's true, but it is still possible to kill objects yourself in C++, even using the shared pointers. It is possible. It's your fault, but it is possible. In Java, I mean, getting a dangling reference error is very difficult, especially by mistake. Yes?
So if you want to copy one object to another and we don't want to point them to same location, we have to assign every data member one by one.
Well, I mean, how do I make a copy of an object really? I mean, this is not an object copy, right? There is no object assignment in Java. How are you going to do that? There is a function named clone. There is a method named clone. And clone is available for all the objects. If it is overloaded, you could do this. You could do this. M1 dot clone. Okay. It's like a copy constructor. Okay. M1 dot clone produces another money object. And in this case, it's going to be clone of M1. So it's going to be $10.20. Now, M2 is pointing to this one. Okay? But clone is not available automatically by default. In C++, we had a default copy constructor, right? In Java, there is a default clone, but it is protected. It cannot be used directly. You have to overload it. Okay, you have to override it, and you have to override it in a proper way. I'm going to show you how to do that. Okay, usually for the Java programmers, they never show. Well, I shouldn't say they never say. They don't show how to copy objects until the end of the semester. Maybe another advanced course in Java in second semester or something. And usually they don't know the difference between cloning an object and making a reference copy. Okay. That's why their code is very efficient actually, because what was the meaning of M2 gets M1? This is very efficient, right? Just pointer copy. Most of the time they do pointer copy. Most of the time they do pointer copy. And they don't realize it. Okay, so good. So, yes.
Instead of that delete line, if I write M2 equals M1 equals
Not
null,
equals, it is assignment.
yeah, I mean assignment, yes.
If you say M1 gets the null, yeah,
both
this
M1 and M2.
What? Both of them. Both of them, M2 and M1 gets null.
Uh, when does that money object is destructed? On
Well,
that line or at the end of the scope?
remember that garbage collector? Objects are killed by the garbage collector, and you don't know when the garbage collector runs. Usually the garbage collector doesn't run if you don't need memory. If you have enough memory, you'll keep collecting those unused objects somewhere in your heap. They will stay there. When the garbage collector realizes that it is now time to run, it will collect all that garbage. Usually for small programs it is at the end of the program, okay? For large programs from time to time. So we don't usually think about the garbage collector returns from time to time. You don't have control of when the object is destructed in Java. At least you don't have full control of when the objects are destructed. I mean, you can force garbage collector to be called. It's called system.gc. Remember system out print line. System.gc calls the garbage collector. But I mean, it is not the everyday life of the Java programmer to call the garbage collector. Usually, we don't think about that kind of stuff in Java. You don't think too deep, okay? It's all abstracted away from you. For a C++ programmer, this is like, I mean, this is not acceptable. I mean, I'm the programmer here. I own the computer. I need to know whatever you are doing, every single line of it. But in Java, no, we ignore that kind of stuff. It will be safe. Don't think about when the objects are going to be killed. Yes.
Can we use null for primitive types?
For what?
For primitive types.
No. There is no null for the primitive types. Integers are always integers. Okay. Any other question? But the Java has a way of knowing if an integer is not initialized. Okay. It doesn't let you use an uninitialized integer. It knows. Good. I think I am out of time, but yes.
You said that everything can convert to string, but there is no string type here.
Well, there is a reference string type, yes. There is a string. The string is not a primitive type, but it's a reference type. Okay?
I don't understand.
What do you mean? I mean, string is a reference type. I mean, it's like the string inside C++. String is a part of STL, right? Standard template library. And in Java, string is not a primitive type, but it's a reference type. Somebody has written string for you, and we are using objects of it. Okay? But again, strings are special. Why? Because it became the part of the language itself, and it is possible to create objects of string without using the new keyword. For example, you can do things like this: string as 1 to A, B. Okay? So this is a literal constant, and I can do this. Okay? So this is only one of the exceptional ways of creating an object without a new operator. But again, string is a privileged class. It's a different class. It's part of the language. It's part of the language. Let me finish this course, today's course, by showing you something that maybe I shouldn't show you at the beginning. But this will kind of show you what kind of thinking they had when they are designing Java. In Java, everything is about objects. Okay? All the classes that you make in Java has to come from this class object. Okay? Object is the base class of all the classes. Whatever you do, it has to be derived from this class object. Okay? Class object methods. Okay? And these are the methods that you inherit automatically. Clone is something that you have inherited. Equals something that you have inherited. Finalize get class hash code and etc. ToString is one of them. Okay. If you are a class, if I write a class in Java like this, class A, objects of this class has all of these methods, including ToString. Okay. If I make a new object like A, new A dot ToString works. It will give you a string.
Can I print like this?
Yeah, you just print it. Well, it's not going to give you something meaningful. It's going to give you the memory address of that object inside the Java virtual machine. Not much meaningful, but it is something. It is a string. So most people usually they override this toString method, and all of them are virtual functions, virtual methods. Okay, and we are going to look at them. Clone is one of them, but it is protected by default. You need to override it. Equals checks for the equality of the two objects. Finalize is kind of a destructor. Okay. Get class and hash code, and we are going to talk about these three are for writing multi-threaded applications in Java. Multi-threaded. Multi-threading.
Don't prevent to blood.
Well, I mean, they are used for multi-threading, yes. It's of synchronization between the threads. Okay? So, I mean, remember what I said? When you make a class like this in C++, your constructor, copy constructor, destructor, copy assignment, move constructor, move assignment are all available. Those be 5 functions. Now I am saying that since all the classes has to be inherited from this object class, an object class define these, then this one has all of them by default. This is a much better way of explaining to the newcomers what kind of things are available for you in Java. Okay? So we are going to look at these methods one by one, and I am going to write maybe one of them. You're going to look at this one. I am not going to look at this one. This one definitely we are going to look at it. And clone, yeah, we are going to spend some time on clone. Okay, good. So tomorrow, read all these slides and try to write some Java code and come back to me with your own error messages, because you are going to get lots of error messages that you don't recognize. Okay, we will talk about those and we will continue. Okay, that's it for today.